Hi, scientists. Today we're going to look at how to write a science lab report, and today we're going to look at the method. If you haven't watched the first video, I highly suggest you watch that first because it will teach you how to write the background information, the hypothesis, and the variables. So just use the QR code to the left to help you with that. This video is the next section called the method section, and it will explain exactly how the experiment was done so that someone else can repeat it. It should include the following: an equipment list, and it's going to be bulleted, and it tells you how many things you need and what size. The setup diagram, if needed, has to be labeled clearly, and you're going to use horizontal lines, and it's going to be in two-dimensional. And lastly is a procedure, and it's going to be written in numbered steps, and it's going to sound like a recipe. So this video is going to teach you how to organize your materials, draw a clear and accurate setup diagram, and write precise, logical step-by-step instructions. So let's look at the method. First, for our equipment list. Again, it's going to be in bullet format. You're going to say what equipment you need and how many and what size. Then you're going to have a setup diagram. Again, only include it if the equipment setup is necessary to show. And remember, you're going to be labeling all your parts with horizontal lines. You'll only use arrows if it's showing a force. And you'll use a pencil, a ruler, and again, drawing in two-dimensional. For the procedure, it's step-by-step instructions for how to carry out your investigation. Again, they should be in numbered form, and they need to be clear and logical. Start with a verb, a doing word, like a recipe. And lastly is the hazards. This is what could happen or what could be dangerous. It would be dangerous because, and then you need to write the action that you would take in order to reduce the risk. Like to be safe, I should, and then you'd explain what you should do. Now let's look at an example. So for my equipment list, this is from the experiment that I'm starting from the first video. So I would need 3 helicopter cutouts, 1 measuring tape, 1 paper clip, 1 pair of scissors, 1 timer, and 1 ruler. And again, notice I have it bulleted. My setup diagram, there is no setup diagram needed for this one, but if I did need a setup diagram, let me show you an example. So for this one, you can see that I have my horizontal lines, and for each one of the parts, I have it written, again, horizontally. It's not written diagonally. Notice there are no arrows because there is no force. And again, it's two-dimensional. For the one that I'm going to be using, I'm going to include this because I have to show how to make the helicopter first, and that's not really going to be part of my procedure. So I just put the information in here. So now let's look at the procedure. You can see that I've numbered it, numbers 1 to 13, and then I'm starting with doing words. Gather, place, go, start, stop, record, cut, attach, repeat. Cut, attach, repeat, repeat. Notice I'm not using any transitional words like first, secondly, those types of things. It's just, again, starting with a doing word. So you're going to start by gathering your supplies. Then place the paperclip at the bottom of your helicopter as shown in diagram B with a wing length of 5 centimeters. Notice that I have 5 centimeters highlighted in yellow. And from the previous video, I had said that anything that's highlighted in yellow is going to be my independent variable. So the wing length of 5 centimeters is my independent variable. Step 3, go to the staircase and hold the helicopter 453 centimeters above the floor as shown in diagram C with wings together. For this, you'll notice I have 3 things highlighted in purple. I have the staircase, the height as 453 centimeters, and the wings together. The purple is my control variables. Again, that comes from video 1. So you can see we have 3 control variables here. For step 4, we're going to start the timer as soon as you let go of the helicopter. That is going to be in turquoise because that's my dependent variable. In other words, what I'm measuring. This is showing me how I'm measuring it. And step 5 says to stop the timer when the helicopter reaches the ground. Again, telling me how to measure it. So step 4 and 5 are my dependent variables. Step 6, record the time in your table. Step 7, cut 1 centimeter off each wing. Again, notice that this is in yellow. It is my independent variable because now the wing lengths will be 4 centimeters. Attach the cutoff pieces to the helicopter, again in purple because it's a control variable. It's something that's going to stay the same within the paperclip. We will repeat steps 3 through 6. And then number 10 is to cut another 1 centimeter off each wing. So now the wing lengths are 3 centimeters. Again, independent variable. Just like in step 8, we're going to attach the cutoff pieces to the helicopter with the paper clip. Again, a control variable. Step 12 is to repeat steps 3 through 6. And step 13 is to repeat steps 2 through 12 2 more times or until results are consistent. For the hazards, there are no hazards for this, but if there were, here's what it would look like. This is from the previous setup diagram that we did. And one of the hazards would be that heating the salt solution is dangerous because the salt can spit. And so an action I can take to reduce the risk is to be safe, I should wear my safety goggles. So here are some key points from this video. Remember that the method section must be detailed and replicable. Use bullet points for equipment, including the quantities and the sizes. Add a setup diagram, only if it helps explain the layout, and again, label the parts properly. Write a clear procedure. Use numbered steps, and again, start each step with an action verb. Think, could someone follow this and do the experiment exactly the same way? If you say yes, you've got a great method. A well-written method equals a reliable and repeatable experiment. If you liked this video, click the like, leave a comment, and if you haven't subscribed yet, please hit the subscribe button. That would be awesome so that you can get more videos on how to write not only lab reports, but also doing mathematics.